In this video, we will demonstrate training a Turtlebot robot with the coach algorithm. Before we begin, we will start with a high-level overview of the platform. Our Turtlebot robot perceives the world using the RGB data from a Kinect camera. We do not make use of the depth channel. Using the RGB data, we design features for detecting the location of specifically colored objects in the environment. In this case, a pink ball and cylinder with an orange top. Perception data is streamed as fast as it can be processed, and every 33 milliseconds, the Turtlebot must make a behavior selection from one of 5 choices based on the most recent frame of data. The 5 behaviors are move forward, backwards, rotate clockwise or counterclockwise, and stay still. All of these behaviors run a fixed velocity for the full 33 millisecond cycle between decisions. By the agent selecting the same movement behavior as the previous one, it causes a smooth continual movement in that direction. To deliver reward and punishment to train the Turtlebot, we use a Nintendo Wii controller, which allows us to give a +1, -1, or +4 reward signal. The +1 and -1 signals are associated with a short eligibility trace, so they primarily affect recent behaviors. Whereas the +4 signal is associated with a long eligibility trace to appraise a large history of behaviors. The controller can also be used to start and pause training. In this video, we will demonstrate 4 different tasks being trained. The first task is a hide task, in which the goal is for the Turtlebot to move away and keep the ball out of its vision. This task is simple, but will demonstrate the basic mechanics of training the Turtlebot. The second task is the alternate task, in which the goal is for the Turtlebot to move back and forth between the pink ball and orange cylinder. In this training example, we will demonstrate how you can train the components of the task separately, and then when combined, result in the desired behavior. The third task is the ball following task, in which the goal is for the Turtlebot to navigate to the pink ball. Here we will show some simple ways to leverage behavioral momentum in training. Finally, we will train the similar task of cylinder navigation. However, in this case, we will show how you can build on top of the ball following task to use the ball as a lure that facilitates the training of multiple behaviors with only one feedback at the end. Keep in mind that the Turtlebot's memory is wiped between the hide, alternate, and ball following tasks, but not between the ball following and cylinder navigation task, since the latter builds on the ball following training. Note that when training the Turtlebot, we have it emit a different noise whenever the trainer gives it a reward or punishment, as a feedback to the trainer that the signal was received. However, in the video, these noises are difficult to hear, so we have placed an additional red circle over the video in the top left corner whenever punishments are being given, and a blue square whenever rewards are being given. Note that the blue square is also shown whenever the +4 reward is given. However, the +4 reward is only used once at the end of the cylinder navigation task in the context of lure training. In all other situations, the blue square corresponds to the +1 reward. Okay, let's get started with the hide task. We begin by training the Turtlebot to move away when the ball is close and in front of it. This involves putting the ball right in front of it and punishing it when it does the wrong behavior, and then adding a number of rewards when it does the correct behavior. Next, we give feedback to get the Turtlebot to rotate when the ball is further away. Finally, we provide feedback so that the Turtlebot stops when no stimulus is present. After this very short training period, the Turtlebot has learned the correct responses to all the stimulus, and we can test it by putting the ball directly in front of it, which causes it to move away, turn when it's farther enough away, and then stop when the ball is out of its vision. For the alternate behavior, we start by training the Turtlebot to move towards the pink ball and rotate once it's close enough. Like before, this involves using punishments and rewards to get to do the right behavior. Here we also continue to give a reward for turning when the ball is not in its vision. In effect, this will cause a seeking behavior so it keeps turning until it finds something. We then pause training so that we can introduce the cylinder and train the Turtlebot the same task but with respect to the cylinder itself instead of the ball. With the cylinder now in place, we resume training and use a similar paradigm as we did with the ball. Since the Turtlebot has now been trained to move forward towards the cylinder, we're going to briefly pause training again and move the cylinder closer so that we can train the behavior of it turning when it reaches the cylinder. With behaviors for the ball and cylinder having now been trained, we will pause training to introduce both. Then we will verify that the Turtlebot correctly combines the behaviors to execute the desired alternate task without any further feedback. With this task successfully trained, we will next move to the ball following task. We will begin this task by first training the robot to stay still. Getting the turtlebot to stay still first allows us to easily position the ball in the near center of its vision and give it additional reward so that it also learns to stay still whenever the ball is near and centered. Next, we disrupt the stay momentum when the ball is to the side with punishment to train it to turn when the ball is near and to the side, and we can repeat this procedure for the other side. We then can verify that the turtlebot turns in the direction of the ball or stops when it is centered. At this point, we've trained what the turtlebot should do when the ball is near, but we haven't trained what it should do when the ball is far. So we'll repeat a similar procedure, except this time we want the turtlebot to move forward when the ball is centered and further away. At this point, we can now verify that the turtlebot follows the ball and stops once it's reached it and centered it. We will now show how by building on top of the ball follow task, we can use the ball as a lure to teach multiple behaviors for cylinder navigation. That is, because the turtlebot is conditioned to navigate to the ball, we can hold the ball over the cylinder so that it navigates to the cylinder. Then we can give a single feedback which will reinforce the history of behaviors for the context in which they appeared. In this case, that will mean rotating when the cylinder is off to the side, moving forward when it is more centered, and stopping once it is near. We will now verify that the behaviors were correctly learned by removing the ball from the scene and see how the turtlebot reacts to the cylinder alone. Indeed, we find that the turtlebot moves towards the cylinder, making corrective turns to keep it centered, and then stops once it has reached it. This concludes our video demonstration of training a turtlebot with reward and punishment. In this video, we showed 4 different tasks being trained: a hide task, an alternating movement task, ball following, and cylinder navigation using the ball as a lure. Thank you for watching.